sorry. This is how I sneeze. I can't sneeze, really. Okay, so now I like to simplify assuming that the variables are positive. So this really means forget about the absolute value. Now we are practicing something else. I don't care for the absolute value. Everything is positive. Okay, all variables or radicands are positive, so now we're just going to practice the rules. So x raised to 1/3, everything divided by x raised to 2/5 multiplied by x to 1/2. This looks messy, doesn't it? Not to worry at all. So the numerator is obviously x to 1/3. The denominator, I copy the base. What do I do with the exponents? We just review them. When I multiply x to 2/5 multiplied by x to 1/2, I apply the first rule. I copy the base. What happens to the exponents? Say it again. Add them. Very good. So 2/5 plus 1/2. Don't even bother with it just yet. Assuming I have a number here, now I'm dividing two exponential notations with the same base. I copy the base, and what happens to the exponents? That's the second rule, I think. Yes, from the exponent of the numerator, I subtract 2/5 and I subtract 1/2. Right? Because I have to distribute to this number. I have to distribute -1. So from the numerator, from the exponent of the numerator, I subtract the exponent of the denominator. So I have minus, minus. Good. How do I add these three fractions? Or if you want to say subtract, it doesn't matter. It's the same procedure. So how do I add or subtract three fractions? What do I have to find? Very good. What is the least common denominator of 3, 5, and 2? Very good. Excellent. Like before, I need adjustments, right? For the top of each fraction. I multiplied 3 by what to get 30? 10. I multiplied 5 by what to get 30? Perfect. I multiplied 2 by what to get 30? Excellent. Please tell me what I have at the top of this fraction, which is the exponent of a base of x, if you want. So 10 minus 12, right? Because it's 6 times 2, and minus 15. Good. Copy the base. 10 minus 12 is -2. -2 minus 15 is -17 divided by 30. I'm sorry? So 10 times 1, 2 times 6, 1 times 15. Better? Perfect. So now I have one of the properties that needs to be applied. Which property I will apply now at the very end of this simplification? Which of all these? The last one, right? 1 divided by x to 17 over 30. Good. But now I'm going to ask also, what is that? What is x raised to 17 over 30? And then we can go back to the very first page in which we said these are the same. So if I see a quantity with a fractional exponent or rational exponent, the same thing, I can change it into a radical. Can anyone tell us what the radical is that? Root of x to the 17th power. Any questions? Any questions?
So you said 30 again? The 30th root?
Yes, the 30th root of x to the 17th power, or raised to the 17th power. Any questions? That's the answer. You're way ahead of me always. Thank you, Jackie. I was going to say one thing here. Not final answer. Since we prefer no radicals in the denominator. And I will explain when we get to that. Maybe even today. Okay? Not the final answer. Only because we don't want radicals in the denominator. Like we don't want negative exponents in a final answer. The same idea. Okay. So now one more example here. X to 1/2 raised to 4/5. It's the next in line anyway. So we're going to come back to this because that's my next step. Okay. So which property from all these will I apply here? Copy the base. Right. So 1 times 4, 2 times 5, but I prefer simplifying. So it's x to 2/5. Now, what radical is this? Because I know it's a radical. As long as it has a power that is a fraction, it must be a radical. So which one is it? The 5th root of x squared. Any questions? Any questions? Okay, so now we're ready to read all this. And let's discuss it. Rationalizing the denominator and sometimes the numerator. That's the reason why we keep no radicals in the denominator. We try. We prefer. Sometimes we will keep them. But not the final answer, since we prefer no radicals in the denominator. Or I should say denominators. Same thing. Okay? So that's why we will be rationalizing the denominator. And yes, sometimes we do the numerator. When the denominator has one radical expression, like this, that's one possibility. And when the denominator has two radical expressions, added or subtracted, like a problem like this. Okay? So I'm going to discuss the first one, and then we'll discuss the second one with examples. So before we look at these two, I want to explain with simpler examples. And I'm going to come back to this. So let's say I have 1 over the square root, or let's say the cube root of 2x squared. Let's suppose after all simplifications, I get to something like this. And I know I would like not to have radicals in the denominator. What I'm going to do is multiply the numerator and the denominator by a radical with the same index, mandatory same index. Okay. Now, how do I want to get the final answer? I would like to get the final answer with no radicals. I like the final answer, the denominator, to be this. This process is called rationalizing. And in this case, we are rationalizing the denominator. Okay. So I'm asking myself this. How do I know which quantity to put in here? And here's the reasoning. I'm looking at the first piece, like the cube root of 2. What power should I have here so that the radical clears completely and the answer is 2? If I put 4, then I will have 4 over 3. That's not going to work. If I put 2, that's not going to work because the power will be 2 over 3. If I put 10, it's not going to work because 10 is not divisible by 3 to get 1. And I don't want to go further than I should. So what should this number be so that when I divide it by 3, I get 1?
3.
Absolutely 3, right? Is that clear? How many 2's do I have? How many 2's do I have here? 1, right? How many more I need, or how many am I missing to get the 3 as the power of 2? That's it. I will think in the same terms for x. The cube root of x to which power will be clearly x? Since I don't really need to go that far, so just 2x. So what power? Of course 3, right? How many x's do I have?
2.
How many am I missing or I should have extra? Exactly 1. That's the process of rationalizing. Now, I hope you agree that when we multiply the denominators, that's what I care about right now. When I multiply the denominators, if I go too far, then I will just have to simplify. And I will still get the same thing at the end. So I hope it's clear that when I multiply these two, I have the cube root of 2 times the cube root of 2 squared, which will be the cube root of 2 to the third. And the cube root of x squared times the cube root of x will be the cube root of x to which power? Copy the base, add the exponents.
Third.
Yes, that's why when I simplify this, what do I get? Exactly what I want. The cube root of 2 cubed, which is 2, and the cube root of x cubed, which is x. And now you can say, fine. But what did you really accomplish? Not much. You took the radical from the denominator in some form and you put it at the top, right? So this expression equals this because I multiplied by 1. This is 1. It's the same thing. So you can say, right, you multiplied by 1 in this form to get rid of the radical in the denominator, but now you created a radical in the numerator. So what's the accomplishment? It's a big accomplishment, and here's why. Number one, this is a much more accurate, I shouldn't say much more, but it's a more accurate answer than this one. Because if you need to calculate this, you will have two approximations. One approximation will be your cube root, and the second approximation will be 1 over your cube root. So you will have tiny more error in this expression than in this one. Because here you only have one approximation and then you divide by 2x, which is division by 2x is much easier than dividing by the cube root, and more exact than divided by the cube root of 2x squared. This is a, if you say it's a minor accomplishment, it's not a big deal accomplishment, true. The mechanism of rationalizing is extremely important in the next courses, in which we rationalize the numerator or the denominator in order to determine a limit or to determine a simplified expression that we set equal to 0 and do something with it. So it's a very important process. It may not seem important here with this example, but it's a very important process. Rationalizing either denominators, mainly denominators, but sometimes the numerators. So this is what I have to do. Let's do another example before we look at that one. And this time you'll tell me what to do. So let's say this is the 7th root of x y squared z to the third. What do I multiply by? Top and bottom. The answer has to be 1. I mean, the fraction has to be 1. I cannot multiply the top by 2 and the bottom by 3. I cannot do that. So what would I multiply by? First of all, it has to be the 7th root. No questions. Good. What am I missing? And now I want to form a perfect what? Before I wanted to form a perfect cube because that's what I had as the index. But what do I want to form now? A perfect 7th. So I have only one x. And I'm short.
6.
Very good. I have 2 y's. So I'm short. And I have 3 z's. Yes, z to the 4th power. Can anyone give us the denominator in a blink without even thinking. That's it. That's how we made it. X times x to the 6 is x to the 7th. The 7th root of x to the 7th is x. Y squared times y to the 5th is y to the 7th. The 7th root of y to the 7th is y. Z to the 3rd times z to the 4th, the 7th root is z. And of course, the numerator is just what I see here. Good? Any questions? Okay, I'd like to look at this one. If you don't want to work on index 7, you can change the index in whatever you want. So just give me an example that you want to work on. I just chose 7th root. Let's choose something else. What example would you like to work on? The 5th, okay. And now make up something underneath. The radical. Let's say 2 squared. Let's say x. And let's say y to which power? 4. Very good. So think for 1 second and tell me what to write. Of course, it has to have the same index, because otherwise I get into big trouble. Big hassle. So in order to finally get 2xy, what do I need? 2 to the, exactly, both top and bottom. I need x to the 4th top and bottom, and I need y. So the numerator will be the 5th root of 8x to the 4th y, and the denominator is 2xy. And I want to say one thing. Please never be tempted to simplify y from under a radical with y that does not have radical. You cannot do that, because this one is y raised to 1/5, and this one is y raised to the 1st power. So you cannot simplify those. Don't be tempted. Okay. What happens now if the denominator is composed by a sum or a difference of terms or radicals? So let's say the square root of x plus 3. How will I think about this? How will I rationalize this denominator? Don't write this because it's wrong. So if I decide to do this, it's not going to help. Why? Because these are 2 terms and I would have to distribute to both. I cannot just distribute to one of them. So the numerator will be this, and the denominator will be, when I multiply these two, I get the square root of x squared. We assume everything is positive, so I get x. So x plus 3, the square root of x. So I did not rationalize the denominator. So this is not the proper way when the radicals, the denominator or the numerator has 2 terms like this. This will not work. This works only when the denominator or the numerator, if I rationalize the numerator, has only 1 term. So this works. Here, with 2 terms, this one does not work. It's not the correct procedure. So I'm going to copy it again. Now I'm going to say, so if you look at the contract, you'll tell me what I need to multiply and divide by. No, you cannot say square, right? I cannot do that. So you cannot say 1/2 and just square it or something. No, I can't do that. So which special product from our contract is applicable now? That will definitely clear the radical in the denominator. There are only 3 on our contract, and I already said that we cannot square. So it cannot be either one of those. So what can it be? what do we think you think you're going to multiply and divide by? If it's not the squared ones, there is only one left.
Square root of x minus 3.
That's it. Exactly. So this is our a plus b times a minus b, and what will the answer be when I multiply a plus b by a minus b, or a minus b by a plus b, doesn't matter. Yes? That's it. As you see, we just run into these three all the time. Either squaring a binomial or multiplying and getting the difference of squares. I have the numerator. What do you think about the denominator? The first term squared. Yes. So the first term squared would be the square root of x squared, which is the square root of x times the square root of x, which is the square root of x squared, which is considered to be x for x positive. And then squaring the second term. So this is the first term squared, and then minus the second term squared. 3 squared is 9. So I would like you to fill it in here for us, for everyone. Which special product was used here? And we're going to look at this example. Which special product was used here? The a plus b, a quantity, multiplied by a minus b, which is, so right here at the end, a plus b times a minus b, which is a squared minus b squared. And now let's look. So remember, these are called conjugates. Conjugates. A plus b, a minus b. So let's look at this example. Let's take it slowly. 2x, the square root of x, minus the square root of y. And let's decide. I said rationalize the denominator, but assuming all variables are positive. But we can choose the other one. Which one would you like to rationalize? We normally rationalize the denominator, but it's up to you. You decide which one you would like to rationalize now. Let's say the problem is asking us, or we can stay with the denominator. You want to stay with the denominator? Okay, very good. So please tell me what we rationalize this denominator by, and which special product we use here. Remember, this is a minus b. What do I need? Good, a plus b. What will that be? Exactly.
2x plus.
Very good. And it has to be the same top and bottom, because this number has to be 1. This fraction has to be 1. Perfect. This step is not trivial. I have to be very careful right now. First, I have to square this and put it here. Then minus, I have to square this and put it here. Okay, so let's do it step by step. So let's take 2x, the square root of x squared. Okay. Remember what we talked about a few minutes ago in the list of properties, the exponential properties. So if I have whatever number of factors inside, each and every factor has to be raised to that power. So first I have to raise 2 to the second power. What do I get? Then I have to raise x to the second power. What do I get? Perfect. Now careful. We already have seen this. When I raise the square root of x to the second power, what do I get? X. So multiplied by x, which turns out to be 4x to the third. Copy the base, add the exponents. So this is my first piece in the denominator. 4x to the third. Now I should not have difficulties raising the square root of y to the second power. The square root of y to the second power, what would that be? Y. So then minus y. The denominator is finished. The numerator, however, is messy. So let's give it a shot. Let's write it out first and calculate later. The square root of x multiplied by 2 multiplied by x and multiplied by the square root of x. I distributed this piece to this term only. And now I'm distributing this piece to this second term. So then plus the square root of x times the square root of y. I finished distributing the square root of x to these two terms. Now, I am distributing negative the square root of y to the first term, and then finally negative the square root of y to the last term. So negative the square root of y times 2x times the square root of x, and then minus the square root of y times the square root of y. Let's look at this one more time before we attempt to simplify it. And let's check step by step what we did. The square root of x times 2 times x times the square root of x. I have it right here. Then the square root of x times the square root of y, which is here. Then minus the square root of y times 2 times x times the square root of x. Minus the square root of y times 2 times x times the square root of x. And finally, minus or negative the square root of y times the square root of y. Is this okay? It's not done. We still have to simplify it. But is it clear? Okay, so now here's what we do. I do know, I'm going to start here. So I do know here that 2 is in front, x. But when I multiply the square root of x by the square root of x, what do I get? X times this x. Very good. So the first term was simplified to 2x squared. Plus, let's see what I simplify the second term to. The two radicals have the same index. All the properties go back and forth. So if you allow me to go back for a second and explain here. When we wrote that the nth root of a times b is the nth root of a times the nth root of b, we can go back and forth. Meaning, if I'm given this, I will split it. If I'm given this, I can condense it. And this is what I'm given at this point. I have the square root of x times the square root of y. They have the same index. I can write plus the square root of, that's it. Now, what do you think about the third term? 2 is 2, x is x, and I have to multiply the square root of x by the square root of y exactly how I did it here. So this is minus 2x times the square root of xy. Very good. Finally, what is this? Which I know now, the square root of y times the square root of y is, yes. And everything divided by 4x cubed minus y. No one can further simplify these expressions. It's done. Why I cannot simplify them? So first of all, these two are not like terms. But you can say, look at this, though. This quantity and this quantity are the same. So they are the same. However, there is no something x in front. So therefore, these are not like radicals. These would have been like radicals if I make that disappear, which I can't. And these I could have simplified. The square root of xy minus the square root of xy, that would be 0. But I can't make that disappear. So I can combine them, and I cannot do anything, and this is final.
If there was no variable, you go to.
Yes. Yes, I would have said an apple minus 2 apples, and I would have gotten -1 apple. So they are not like radicals because this is in the way. And I want to emphasize something. It will be a terrible mistake to simplify this with this. We know that these are not factors. This is a term in a chain of 4 terms, and this is a term in a chain of 2 terms. So you cannot attempt to simplify anything. This is it. Done. Any questions so far? Any questions? Okay, I would like to have another example, but this was taking it a little bit too extreme. So make one up for us and tell me which one would you like to rationalize. We're going to go to the book and we're going to, emphasize each and every topic again from the beginning. I don't want you to do anything on this chapter yet because I have not. I went to step by step through the concepts, but we didn't really practice. So from Tuesday on, I'll go back to each and every section in the book, and we'll choose examples from each and every one of them. So you don't have to do anything unless you want to. Okay, give me an example with 2 terms that we can rationalize. Anything you want. Okay, I'll put the top as 4x minus y, and you give me whatever you want in the denominator. And we will rationalize the denominator. What would you like to have? I would have x plus y. You'll make up the next one. I know I only have 10 minutes left, I know. So how do I rationalize the denominator? Can I rationalize the numerator? There are no radicals in the numerator. There is no need to rationalize the numerator. So only the denominator needs to be rationalized. So what do I need to rationalize it with? And remember what we wrote here. This is our special product that we need to use whenever we need to rationalize. We use it when we rationalize a quantity with a radical, or 2, but definitely a sum or a difference, like this one. So what do I need?
Square root of x plus square root of x.
That's it. Good. So now the denominator should not give you any headache. Boom. What is it? X minus y, the difference of squares. Good. So now the numerator, you can distribute or not. I'm fine if you just write this. I really am. And there is nothing else. You don't need to do anything else. Any questions? Any questions? Okay. Yes, please. Yes, Becky.
Can I see your notes?
Yes. Absolutely. This is something that we covered weeks ago. Graphs of radical functions, the square root and the cube root. There is nothing new here in the top part of this page. Remember the graph? Is this the graph? I graphed it with a mathematical software, and I just want you to give me the domain of this function. I want us to graph it here. We already have the graph because I wanted you to have it on the page, but I like to graph it again here. And we've done this before. It's not the first time. So what do? I look at the square root of x and I say, oh, the index is even. This is not a friendly function. How do I determine its domain? What do I have to write?
X is greater than or equal to.
Absolutely. So I have to write that x must be greater than or equal to 0. Therefore, the domain of this function is, this is not new. This part, the top part is not new. The domain is, very good. So between 0 and infinity, I will pick some numbers and I have to pick 0. So give me a couple of numbers, 3 numbers. So 0 plus 2 more numbers. Okay. I cannot, I mean I can, but the square root of 2 is 1.41. 1, very good. And give me one more. Okay. So the square 8 is a problem again. So the square root of 0 is, the square root of 1 is, the square root of 4 is, the square root of 9 is, that's it. So I have the graph. The first ordered pair that you will tell me to plot. Perfect. Next ordered pair. Next ordered pair. I went too far. I don't really need that anyway. So here's the graph. This is the graph of the square root of x. We've graphed it many times before without even knowing much about radicals. And now I would like to identify the range. You told me already several times. What is 0 to infinity? A radical function is a function. I'm sorry, erase the s. A radical function is a function defined by an expression containing absolute value. No. Containing a square root or a radical. Very good. A radical. It cannot be called a radical function if it doesn't have a radical in it. It cannot be called an absolute value function if it doesn't have the absolute value, right? Good. Okay, and now after this, I promise to stop. Can anyone give us the domain of the cube root of x? We have not seen this graph yet. Exactly. Friendly function, no problem. And we'll figure out the range in a minute. So then between negative infinity and infinity. And I'm expecting 5 numbers. Yes? Better negative 1. 1. And give me another cube. Exactly. That's all I wanted. Plus or minus 1, plus or minus 8, and 0. Please plug in negative 8 in the function. We have it on the first page, actually. When I plug in negative 8, what do I get for the cube root of negative 8? Excellent. When I plug in negative 1, what do I get for the cube root of negative 1? Yes. When I plug in 0, what is the cube root of 0? What is the cube root of 1? Nice. What is the cube root of 8? 2. Okay. Look how nice the function is, and it's also symmetric. Okay, negative 8. 2, 4, 6, 8, negative 2. Negative 1, negative 1. 0, 0. 1, 1. No. Okay, it's here. 1, 1. And 2, 4, 6, 8, 2. It's not a straight line. Do not graph it as a straight line. Mine kind of looks like a straight line. It's not. So can anyone give us the range of this function? Yes. Friendly function. No headache. No difficulties with the domain. No difficulties with the final answer. Anything goes in odd indices, inside and outside. So again, you can look at the problems, but I would prefer you not. I hate to say not give you anything to do for Tuesday, but